Welcome to the Dream Architect channel. Today we will journey into the quiet heart of the polar night to witness a celestial ballet, the Northern Lights. This is a journey not to a place on a map, but to the very edge of our world, where the sky becomes a canvas for a cosmic artist. We will watch as invisible streams of energy take on the form of light, dancing above the frozen earth. This is the story of how the breath of a distant star becomes a lullaby for our planet. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul after another. And now, just breathe, let your eyes grow heavy and your mind soften. Let us begin. Imagine that the night can not only hide the stars, but also paint with its own light, using silence for a brush and the celestial dome itself for a canvas. It is in this way, in the deep darkness of the polar circle, that the Northern Lights are born, when the velvet curtain of night suddenly comes to life, colored by a silent, slow dance. Giant jade-green ribbons bend and sway, like silk banners moved by an invisible cosmic wind, now flaring up almost dazzlingly, now softly fading to a ghostly glow. This is not just a light in the darkness. It is a quiet promise of a miracle, given by eternity itself, a reminder that the deepest darkness holds the most tender radiance. This silent dance has a name, given to it at the dawn of a new era, a name in which the whisper of ancient myth meets the voice of nascent science. Imagine the year 1619, the great Galileo Galilei, the man who pointed his telescope at the mountains of the moon and the moons of Jupiter, turns his gaze to the mysterious glow in the north. He does not see spirits or gods in it. He seeks an explanation. And he gives the phenomenon a name, Aurora Borealis. Aurora, that is what the Romans called the gentle goddess of the morning dawn, who opened the gates of day with her rosy fingers. Boreas, that is what the ancient Greeks named the harsh god of the north wind. This single phrase contains the entire paradox of the phenomenon. The tenderness of dawn, born in the icy breath of midnight, assigning to this light the image of a dawn that has lost its way in time and space. Although we call it northern, this celestial fire has a twin brother at the opposite pole of the planet, invisible to most of us. There, over the icy desert of Antarctica, exactly the same spectacle unfolds, bearing the name Aurora Australis, or the Southern Lights. They are perfect mirror images, born from the same cosmic breath. When a stream of solar plasma reaches the Earth, it splits, and its parts rush toward both poles simultaneously, like a river flowing around an island. Therefore, at the very moment a green flame blazes over the Arctic, the same ghostly performance unfolds over Antarctica, visible only to penguins and the few researchers at lost stations. 2 poles, 2 dances, 1 lullaby for the entire planet. This ghostly glow does not belong to Earth. It is a distant guest that has traversed an inconceivable distance of 150 million kilometers. It all begins not here, but there, in the incandescent heart of our system, on the surface of the Sun. In its boiling cauldron of plasma, where temperatures and pressures reach unimaginable values, the solar wind is born, a continuous, invisible stream of charged particles, mostly electrons and protons. It flies out in all directions at speeds of hundreds of kilometers per second, carrying colossal energy. This wind is invisible and imperceptible to us, but it is like the breath of a star, which upon reaching our world is capable of igniting the firmament. This cosmic breath does not reach us instantaneously. Its journey through the emptiness of interplanetary space takes from 2 to 4 Earth days. All this time, the invisible stream of plasma rushes through the vacuum, preserving within itself the exact imprint of the solar activity at the moment of its birth. Scientists, by observing flares on the Sun, have learned to read these signs and can predict with high accuracy when a geomagnetic storm, and consequently a bright aurora, will begin on Earth. This knowledge turns the anticipation of the aurora into a kind of meditation, a listening to the deep rhythms of the cosmos, a patient waiting for the arrival of this unseen messenger from the very heart of our system. Sometimes our sun does not just breathe, but seems to sneeze, ejecting a gigantic dense cloud of plasma into space, known as a coronal mass ejection. This event is like an invisible cosmic tsunami that rushes toward Earth with even greater speed and crushing force than the ordinary solar wind. It is such powerful, though rare ejections that give rise to the most impressive and large-scale auroras, which can be seen far beyond the usual polar latitudes. This is a quiet yet formidable reminder that even the calmest sky above our heads is connected by invisible threads to the violent processes occurring on our distant and so very native star. But our planet is not defenseless against this furious cosmic wind. It is enveloped in an invisible force field, like a fragile fruit with a thin but strong peel. This field is the Earth's magnetosphere, our silent and faithful guardian. It is born in the very heart of the planet, thanks to the slow movement of molten iron in its core, and extends into space for tens of thousands of kilometers. When the stream of solar particles reaches Earth, it is the magnetosphere that meets it first, deflecting and reflecting most of the deadly radiation. It forces the stream to flow around our planet, just as water flows around a smooth stone in a vast river, allowing only a small, safe portion of it to penetrate inside. This invisible shield is not a perfect sphere. It is asymmetrical, constantly distorted by the pressure of the solar wind. On the side facing the sun, it is compressed and flattened, while on the night side, conversely, it is stretched into a long, fluttering tail, similar to a comet's tail, that extends for millions of kilometers deep into space. This strange dynamic shape plays a key role in the birth of the aurora. It is in this long magnetic tail that energy accumulates, as if in a giant capacitor, which then explosively releases, causing the celestial glow. Our invisible shield has its own complex and living architecture. The lines of Earth's magnetic field are like invisible rails or arteries, along which trapped particles of the solar wind travel. These lines emerge from the region of the south magnetic pole, and curving through space, enter the region of the north one, forming giant, unseen loops. Charged particles, once inside the magnetosphere, cannot move chaotically. They begin to slide along these field lines, spiraling tightly, like tiny beads strung on an invisible thread of the universe. It is this strictly directed motion that brings them to the upper layers of the atmosphere over the polar regions, where they are destined to perish in a final flash of light. The aurora does not appear just anywhere in the sky, but in a strictly defined region that encircles the Earth's magnetic poles in a ring. This region is called the auroral oval. It is not a static ring, but a living, breathing structure whose size and position constantly change depending on solar activity. On calm nights, the oval contracts and the aurora, is visible only in the highest latitudes close to the pole. But during strong magnetic storms, it expands, swells, and then the celestial dance can be observed in Scotland, the northern states of the USA, and even, in the rarest of cases, on the shores of the Mediterranean. The auroral oval is the visible boundary of our world, pulsating in time with the sun's breath. Contrary to popular belief, the aurora is not a uniform phenomenon. It has many forms and characters like different genres in celestial music. Calm arcs are the simplest and most common forms, resembling pale greenish rainbows frozen motionless in the sky. Active bands or curtains are what we most often see in photographs. Dynamic, shimmering structures with distinct vertical rays resembling silk. And the rarest and most impressive form is the corona, which occurs when the aurora is directly over the observer's head. At this moment, the rays converging at a single point create the illusion of a giant crown pulsating with light directly above you. The altitude at which this celestial fire is born is immense. It occurs far beyond where airplanes fly or familiar clouds form. The lower edge of the brightest green auroras is usually at an altitude of about 100 kilometers above the Earth's surface, where the atmosphere is already extremely thin. The upper boundary, however, can extend to 400 kilometers and even higher, reaching the orbit of the International Space Station. This means that astronauts on the ISS see the aurora not above them, as we do, but below them, watching as a living, glowing carpet spreads out over the night side of their home planet. The color of the aurora is not an artist's whim, but a precise chemical autograph of our atmosphere, a visible imprint of its composition. The most common and recognizable color, an ethereal green, is born the moment fast-moving charged particles collide with oxygen atoms at an altitude of 100 to 300 kilometers. This is a kind of signature color of the aurora, to which our eye is most sensitive in the dark. It appears in the same region of the atmosphere where meteors burn up, turning the night sky into a silent stage for countless quiet cosmic dramas. Sometimes during the most active and turbulent nights, delicate red or crimson hues can be seen above the main green ribbons like reflections of a distant fire. This color is also created by oxygen atoms, but at much higher altitudes, over 300 kilometers. There, the atmosphere is so rarefied that oxygen atoms, after a collision, can remain in a special, forbidden for lower altitudes, excited state for a very long time before emitting a photon of red light. This glow is so faint and high that it can often only be captured with a long exposure camera, like the rarest and most elusive color in the celestial artist's palette. If you look closely at the very bottom edge of the fastest and most active luminous curtains, you can notice a shimmering pink or purple fringe. This delicate color is the result of the collision of the most energetic particles with nitrogen molecules, the main gas of our atmosphere, at altitudes of about 100 kilometers. Nitrogen, when excited, emits light predominantly in the blue and violet parts of the spectrum. When this cool light mixes with the main green glow of oxygen, it creates this almost living pinkish border, which emphasizes the dynamics and speed of the celestial dance, like a final stroke on a painting. And then there is the blue and violet aurora, the deepest and most elusive of all. It is also generated by nitrogen molecules, but it requires the solar wind particles to be so energetic that they penetrate to even lower altitudes, below 100 kilometers, where the atmosphere becomes denser. This happens only during very powerful geomagnetic storms. The blue and violet tones are at the very limit of our night vision's sensitivity, so most often they remain invisible to the naked eye, revealing themselves only in long exposure photographs, like a secret, intimate language of the sky, which it uses only in moments of greatest excitement. The aurora does not burn with a steady flame. It breathes, pulsates, flares up, and fades in a complex rhythm dictated by invisible processes in the Earth's magnetosphere. Sometimes one can observe so-called pulsating auroras, separate patches of the sky that begin to rhythmically flicker with a period of several seconds, like a giant cosmic heart or a distant lighthouse. This rhythm is associated with complex wave processes in the plasma surrounding our planet. Observing these pulsations is a deeply meditative experience, allowing one to feel the living, measured pulse of our planet responding to cosmic flows. The speed of the luminous curtains of the aurora can be truly astonishing, although from a distance they seem slow and smooth. In reality, these light structures can move across the sky at a speed of several kilometers per second, which is tens of times faster than the speed of sound. What we perceive as a graceful and unhurried dance is actually the visualization of supersonic energy flows invading the upper layers of the atmosphere. It is a silent storm, raging in the absolute silence of space right above our heads, magnificent and completely soundless. Despite its grandeur and apparent density, the aurora is completely transparent and intangible. It is so rarefied that distant stars are perfectly visible through its brightest flashes, as if through colored glass. It is not a cloud or a fog. It is simply the glow of the atmospheric gas itself, as rarefied as the deep vacuum in terrestrial laboratories. You could fly through it in a spaceship and not even notice, if not for the instrument readings. The aurora is a beautiful phantom woven from pure light, an intangible miracle that can be seen but cannot be touched. There is a long-standing and elegant debate about whether the aurora produces sounds. For centuries, many observers from northern peoples have sworn they could hear a quiet crackle, a barely perceptible hiss, or a rustle during particularly bright displays. For a long time, science categorically denied this, as the aurora is located too high, at an altitude of 100 kilometers, for sound from there to reach the ground. However, recent research by Finnish scientists has confirmed that the sounds do indeed exist. They are not born at the altitude of the aurora, but much lower, almost at the very ground, in the temperature inversion layer, due to the powerful electromagnetic fields associated with the aurora. This sound, known as the auroral crackle, is incredibly quiet and can only be heard in conditions of absolute silence, far from any signs of civilization, in the deep cold. It is similar to the sound of static electricity when you take off a wool sweater, or to the quiet rustle of dry leaves underfoot. This is not the sound of the aurora itself, but rather its acoustic echo, born here, near us, in our world. The realization that the celestial dance can have its own, barely audible voice adds even more mystery and depth to this phenomenon. Although the aurora seems as cold as ice to us, it is actually the result of the release of a huge amount of heat in the upper layers of the atmosphere. The temperature of the gas where the glow occurs can reach thousands of degrees Celsius, which is comparable to the temperature of molten lava. However, the air there is so infinitely rarefied that there is simply nothing for this heat to transfer to. The distance between molecules is too great. Therefore, standing on a snow-covered plain under the blazing celestial fire, we feel only the deep frost of the polar night. This is the great paradox of the aurora. Fiery in nature, it is forever linked in our perception with the sensation of cold and ice. The energy released during a single aurora of average intensity is truly colossal and difficult to imagine. It is comparable to the energy generated by a large nuclear power plant in several hours. And during powerful geomagnetic storms, when the aurora covers half the sky, this figure can exceed the annual electricity consumption of some small countries. All this unimaginable power is transformed into a silent, ephemeral glow that lasts only a few hours and then disappears, reminding us of the scale of the forces at work in the universe and of how little energy is needed to create beauty. Powerful auroras are not only a breathtaking spectacle, but also a visible indicator of space weather, which can have a very real impact on our technologies. Geomagnetic storms, which cause the brightest auroras, can trigger malfunctions in communication satellites, disrupt GPS navigation systems, and create interference in radio communications. They can even induce powerful stray currents in long power lines and pipelines, leading to large-scale power outages. Thus, the celestial beauty gently reminds us of its hidden power and our dependence on fragile technologies. The most powerful geomagnetic storm in recorded history, known as the Carrington event, occurred in September 1859. The auroras then were so bright and global that they were seen even in tropical latitudes in Cuba, Jamaica, and Hawaii. In the Rocky Mountains of North America, it was so bright that gold prospectors woke up in the middle of the night, thinking it was dawn, and started preparing breakfast. Telegraph systems worldwide failed, and some devices even caught fire from the induced currents. This event serves as a formidable reminder of the potential power of our sun. The aurora is not a unique phenomenon exclusive to Earth. This process is universal and is observed on any planet that possesses two key components: an atmosphere and a sufficiently strong magnetic field. Using the Hubble Space Telescope, astronomers have captured stunning images of auroras on the gas giants, Jupiter and Saturn. Their auroras are many times more powerful and larger than Earth's, forming luminous rings around the poles that exceed our entire planet in area. Space is full of these silent lights. The auroras on Jupiter are the most powerful in the entire solar system, true celestial monsters. They are fueled not only by the solar wind, but also by a constant stream of particles ejected by the giant volcanoes on its moon, Io. Because of this, the auroras on Jupiter are permanent. They never cease, forming eternal, incredibly bright luminous crowns at the planet's poles. However, unlike Earth's auroras, they shine mainly in the ultraviolet range, invisible to our eyes, but no less magnificent for it. It is an eternal celestial fire, blazing on the giant planet. Even on Mars, a planet that long ago lost its global magnetic field and most of its atmosphere, its own ghostly auroras have been discovered. They do not occur at the poles, but in specific regions of the crust, where patches of residual magnetism have survived, like ghosts of a long-gone magnetic field. These Martian auroras are faint and bluish. They tell a quiet and sad story of what the red planet might have been like in the distant past, when its core was still active, and its sky, perhaps, was as alive as ours. But let's return to Earth. to our own terrestrial aurora. Its form and dynamics are directly linked to the complex structure of the magnetosphere. Calm, stationary arcs correspond to stable, laminar flows of particles. In contrast, turbulent, rapidly changing curtains and flashes occur during a process called a magnetospheric substorm. This is akin to a short circuit in Earth's long magnetic tail, where the stored energy is explosively released and rushes toward the poles. The dance of light in the sky is merely the visible manifestation of these invisible cosmic cataclysms. Sometimes within the bright canvas of the aurora, one can see dark, almost black structures, patches, swirls, and bands that move along with the light. This is not simply an absence of the aurora, but a special type of it, the so-called black aurora. Scientists have discovered that these are regions where electrons are not accelerated downward into the atmosphere, but on the contrary, are pulled upward, back into space, creating voids in the particle stream. These dark swirls and bands are just as dynamic as the bright parts, and are an integral part of the aurora's complex electrodynamics. They are a shadow that dances with the light, proving that even in light, there is its own darkness. Our eye is not always able to capture the true colors of the aurora, especially when it is faint and just beginning. The fact is that our night vision, for which the rod cells in the retina are responsible, is more sensitive to brightness than to color. Therefore, a faint aurora often appears to us as simply whitish or grayish, resembling a distant cloud or a band of fog. And only when the intensity of the glow increases do the cone cells come into play, and we begin to clearly distinguish its signature green hue. A camera with a long exposure by accumulating light sees far more colors than we do. Photography has brought about a true revolution in our perception and understanding of the northern lights. The first successful photograph was taken as early as 1892, but it took decades for the technology to allow it to be captured in all its beauty and dynamism. Modern digital cameras with their high sensitivity allow not only for capturing bright and vivid colors, but also for creating time-lapse videos, accelerating the slow dance of light and turning it into a swift, breathtaking vortex. Photography has revealed to us the beauty of the aurora that was previously hidden from the naked human eye. Observing the aurora requires not only luck, but also patience and specific conditions. The best time is during the dark, moonless nights from September to March, when the nights are long and cold. It is necessary to get as far away as possible from cities, whose lights create light pollution and drown out the faint glow of the aurora. And of course, a clear, cloudless sky is needed. Sometimes one has to wait for hours in the cold, peering into the darkness before the first pale green arc appears in the sky. But this waiting, this listening to the silence, is an integral part of the ritual. The best places in the world for observing the northern lights are located along the so-called auroral oval. These are the northern regions of Norway, Sweden, Finland, all of Iceland, southern Greenland, as well as the northern territories of Canada and Alaska. Each of these places offers its own unique and majestic landscape, which becomes a natural backdrop for the celestial spectacle. Whether it be snow-covered fjords, tundra stretching beyond the horizon, or icy lagoons with icebergs. In these moments, earth and sky enter into a silent dialogue, creating scenes of unparalleled beauty. There is a great cosmic rhythm that governs the frequency and power of these celestial displays, the 11-year cycle of solar activity. Approximately every 11 years, our Sun reaches its maximum, when the number of sunspots on its surface, the frequency of flares, and coronal mass ejections sharply increase. During these years, the polar auroras become especially frequent, bright, and large-scale, and the auroral oval expands significantly to the south. Then comes the solar minimum, and the auroras become rarer and calmer. This cycle is like the slow heartbeat of our star, marking the epochs of celestial fire. In ancient times, when science could not yet explain the nature of this celestial light, people created myths to make sense of this grand and frightening phenomenon. In Norse mythology, for example, it was believed that the aurora was the gleam of the armor and shields of the Valkyries, Odin's maiden warriors. They would sweep across the night sky on their winged horses, choosing the bravest fallen warriors and carrying their souls to Valhalla. The celestial light was an echo of epic battles, a bridge between the world of the living and the halls of the gods, a visible sign of eternal glory. Another Norse myth, no less poetic, associated the aurora with the Bifrost Bridge, a rainbow shimmering and iridescent bridge that connected Midgard, the world of humans, and Asgard, the abode of the gods. It was believed that it was along this living, glowing bridge that the gods descended to Earth and returned. To see the aurora meant to see a path to another higher world, to feel the unseen presence of the divine in the night sky. It was an awe-inspiring and reverent spectacle, full of profound meaning. The Finns, neighbors of the Scandinavians, called the northern lights Revontulet, which literally translates to foxfires. According to their ancient and beautiful legend, the aurora is caused by a mythical firefox that runs with incredible speed across the fells of Lapland. When its huge furry tail touches the snowdrifts and treetops, myriads of multicolored sparks fly up into the sky, forming the celestial glow. This poetic image surprisingly accurately conveys the swiftness, lightness, and playfulness of the celestial dance, turning it into the play of a magical beast. For the Sami peoples, the indigenous inhabitants of northern Scandinavia and the Kola Peninsula, the polar lights were a living and powerful phenomenon that was to be treated with the utmost respect and caution. They believed that these were the souls of deceased ancestors who had come to visit their descendants. During the aurora, one was not supposed to make noise, whistle, sing, or wave one's arms, so as not to disturb the spirits and bring misfortune upon oneself. It was a time for quiet contemplation, silence, and reflection on the unbreakable bond between generations, on life and death. The Eskimo peoples of Greenland and North America also believed that the flashes of light in the sky were the souls of the dead. But in their view, the ancestors were not just watching the living, but were playing their own celestial game, similar to football. The ball, according to some versions, was the skull of a walrus. The knocking sound they supposedly heard during the game was the very same mysterious crackle that sometimes accompanies the aurora. This belief turned the celestial glow into a reminder of the afterlife and the eternal cycle of being, where death is merely a transition to another game. Even in Scotland and the north of England, where the aurora does not appear as often, it had its own name, the Merry Dancers. This name perfectly reflected the playful and dynamic character of the phenomenon, its constant movement and changing forms. However, as in many cultures located further south, the aurora was often also considered a bad omen, a harbinger of war or coming misfortunes. Its red color, rare in these latitudes, was strongly associated with blood and future battles, tinging its beauty with anxiety. In North America, the Cree Indians believed the aurora was a dance of the spirits of great hunters and chiefs. They also thought that one could communicate with ancestors by whistling softly in unison with the movement of the light in the sky. This was a form of respectful dialogue with the otherworldly realm, an attempt to connect with those who had passed on and to receive their advice or blessing. The sky became a giant membrane between worlds, vibrating with light and meaning, accessible only to those who knew how to listen. Even in China and Japan, countries where the aurora can be seen only once every few decades or centuries during extreme storms, ancient records of this phenomenon exist. There, it was often interpreted as celestial dragons, good or evil, battling in the night. The red color of the aurora was considered a particularly important sign, often associated with the birth or death of an emperor, the beginning of a new dynasty, or another fateful event. Distant echoes of the polar miracle found their place even in cultures for which it was the greatest of exoticisms. The first scientist to undertake a serious attempt at a systematic scientific study of the aurora was the Norwegian physicist Christian Birkeland at the end of the 19th and beginning of the 20th century. He was obsessed with this mystery and hypothesized that the aurora was caused by streams of electrons emitted by the sun and guided toward the poles by the Earth's magnetic field. To prove his theory, he created an amazing model in his laboratory, a magnetized sphere called a terrella in a vacuum chamber. When he directed a beam of electrons at it, a glow appeared around the sphere's poles, strikingly similar to the aurora borealis. Birkeland's theories were so far ahead of their time that they were not fully accepted by the scientific community during his lifetime. Many considered his ideas fantastical. It was only with the dawn of the space age, when satellites were able to directly measure particle flows in space and confirm the existence of currents flowing from the sun to the Earth, that his brilliant correctness was fully proven. Today, Birkeland currents, giant electric currents flowing along magnetic field lines and feeding the auroras, are named in his honor. The story of his life is a story of a genius who peered beyond the horizon of his era. If we set aside poetry and look at the physics of the process, the aurora is, in essence, a giant natural old-fashioned television screen. The role of the cathode ray tube in this television is played by the Earth's magnetosphere, which focuses and accelerates electrons flying from the sun. And the role of the phosphor screen is played by the upper layers of our atmosphere, which begin to glow in different colors when these electrons hit them. We are observing the physical process underlying old cathode ray tubes, but on a truly cosmic, planetary scale. The thickness of the glowing layer of the aurora, which appears voluminous and deep to us, can actually be surprisingly small. Often, it is only a few hundred meters or, in extreme cases, a couple of kilometers. What we perceive as massive, three-dimensional curtains swaying in the depths of the sky are actually very thin. Sheets of light that, due to the play of perspective and our position, appear deep and voluminous to us. This is another beautiful optical illusion created by this celestial phenomenon, an illusion of depth where there is only a thin, glowing sheet. The vertical rays from which the aurora's curtains and crowns are woven are nothing other than a precise visualization of the Earth's invisible magnetic field lines. The particles, as we recall, can only move along these lines, and upon colliding with atoms in the atmosphere, they cause narrow corridors of gas along their path to glow. Therefore, when looking at the structure of the aurora, we are literally seeing the architecture of our planet's magnetic field at that specific moment. This makes the spectacle not only beautiful, but also deeply informative for those who know how to read these fiery celestial scripts. When the aurora is directly overhead, it often forms a shape called a corona. This impressive shape is purely an effect of perspective, not some special physical structure. At this moment, we are looking directly along numerous parallel rays of light, extending upwards for tens of kilometers. And they, like railway tracks receding to the horizon, appear to us to converge at a single point high in the sky, at the so-called magnetic zenith. It is merely our viewing angle that transforms the parallel lines into a radiant, pulsating corona crowning the night sky. Unlike a rainbow, whose position always depends on the observer's position relative to the sun and water droplets, the aurora is an objective physical phenomenon occurring in a specific location in the atmosphere. Two people standing several kilometers apart will see the same aurora, but from slightly different angles. They can even call each other on the phone and simultaneously point to the same bright glowing fold in the celestial curtain. The aurora is real. It exists up there, regardless of whether we are looking at it or not. Sometimes, in very rare cases, auroras have been observed whose lower edge seemed to reach the mountain peaks or even touch the ground. These are most likely complex optical illusions related to perspective and terrain, but they have given rise to many legends about being able to touch or enter the aurora. In reality, even its lowest edge is at an altitude of over 80 kilometers, which is 10 times higher than Mount Everest. The aurora always remains unattainable. It hovers above the mortal world as a reminder of the boundary between the earthly and the celestial. Auroral activity and the associated geomagnetic storms can affect the migrations of some animal species. It is believed that migratory birds, whales, and even some fish, which use the Earth's weak magnetic field for navigation like an internal compass, can become disoriented during strong cosmic disturbances. Their internal compass is thrown off, and they may deviate from their customary, millennia-old routes. Thus, space weather, born 150 million kilometers away, interferes with the delicate biological rhythms of our planet. There is a type of aurora that is completely invisible to the human eye, but is constantly recorded by sensitive instruments on satellites. This is the so-called dayside aurora, which occurs on the dayside, the sunlit side of the Earth. It is much fainter than the nighttime aurora, and is completely lost in the bright blue light of scattered sunlight. But it is there, as a quiet and constant reminder that the solar wind never ceases its interaction with our planet, even when we do not see or feel it. Another unusual type of aurora, invisible to us, is the proton aurora. It is caused not by electrons like a regular aurora, but by heavier particles of the solar wind, protons. This aurora is very wide, diffuse, and it glows mainly in the ultraviolet range, remaining invisible to our eyes. It often precedes brighter electron auroras and serves for scientists as a kind of harbinger of the coming celestial spectacle. It is a quiet, invisible overture to the main performance that is about to begin. In 2016, an amazing event occurred. Amateur scientists, aurora photographers, discovered a completely new type of atmospheric glow associated with auroral processes. They jokingly named it Steve, and the name stuck. This is not a typical aurora, but a narrow ribbon of purple light stretching for thousands of kilometers, which appears at lower latitudes and is sometimes accompanied by a green picket fence of vertical stripes. Steve is the trail of a very hot and fast flow of gas in the ionosphere, and its discovery showed that even in such a seemingly well-studied phenomenon, new mysteries still await us. Unlike the classic Aurora, which can dance in the sky for hours, the Steve phenomenon is short-lived, lasting from 20 minutes to an hour, and then disappears without a trace. The physics of its origin differs from that of a regular aurora. It is not directly related to the precipitation of particles into the atmosphere, but is the result of other, not yet fully understood processes of interaction between electric and magnetic fields. Its warm, gentle lilac glow is another line in the great poem that the sky writes every polar night, a line we have only recently learned to read. For the indigenous peoples of the North, the aurora was not only an object of myths and superstitions, but also a quite practical guide. By its position, shape, and brightness, experienced hunters and reindeer herders could predict the weather for the coming hours. It was believed that a bright, high, and dancing aurora foretold the continuation of clear and frosty weather, whereas a low, dim, and stationary one indicated imminent warming, cloudiness, and snowfall. These folk omens had a real basis, as auroral activity is closely linked to the movement of high-altitude atmospheric fronts. In Iceland, the land of volcanoes, glaciers, and harsh sagas, there was a peculiar belief associated with the aurora. It was believed that the northern lights ease the pain of childbirth, but the woman in labor must under no circumstances look at them, or the child will be born cross-eyed. This strange myth mixes hope and primal fear, reflecting the dual nature of the perception of the aurora, as something beautiful and divine, and at the same time powerful, dangerous, and otherworldly. Despite its apparent chaotic nature, there is almost always a certain sequence and logic of development in the dance of the aurora. Often, the display begins with a calm, barely noticeable arc hanging motionless on the northern horizon. Then, as solar activity intensifies, the arc begins to bend, folds appear on it, and it transforms into an active moving band. The culmination is often an auroral explosion or breakup, when the entire sky is illuminated with fast, chaotic rays and patches of light. After this, everything slowly subsides again, preparing for a new cycle. The aurora can be not only a global phenomenon, but also an incredibly local one. Sometimes one can observe a narrow yet bright band of light passing directly over your village or house, while just a few kilometers away, the sky remains completely dark. This is because the streams of particles causing the glow can be very narrow, like threads, only a few hundred meters wide. In such a moment, you might be the sole spectator of this personal celestial show, which the universe seems to have arranged just for you. One of the most mysterious and beautiful aspects of the aurora is its fine, almost fibrous structure, visible under high magnification or in high-quality photographs. If you look closely at the rays, you can see that they, in turn, are composed of even finer, constantly moving and changing threads of light. This fine structure is still a subject of active research and debate. It suggests that the processes governing the movement of plasma in the magnetosphere are even more complex, elegant, and turbulent than we could have imagined. Astronauts observing the aurora from the orbit of the International Space Station often describe it not as a physical phenomenon, but as a living, breathing creature. They see giant waves of light ripple across it for thousands of kilometers, and how it pulsates in time with invisible cosmic rhythms. To them, it is not just light above, but a glowing, living aura of their own world, constantly changing and indescribably beautiful. They see not just an aurora, they see the aura of planet Earth, its breath turned towards space. In the Middle Ages, the rare appearances of auroras in Central and Southern Europe, especially blood-red ones, caused mass panic and primal terror. They were considered indisputable omens from God, harbingers of plague, famine, war, and the end of the world. Chroniclers of that time left us gruesome descriptions of fiery spears, celestial dragons, and entire armies battling in the night. People, unaware of the phenomenon's true nature, saw in it only a reflection of their deepest fears and anxieties. During World War II, Allied pilots on night flights over occupied Norway for bombing runs, or to support the resistance, sometimes mistook sudden, bright flashes of the aurora for the lights of fires or explosions below. This shows just how intense and unexpected the glow can be. The sky itself became a battlefield of light and darkness, silently echoing and reflecting the terrible dramas unfolding on the ground beneath it. Some modern scientists hypothesize that intense auroras can influence the formation of the highest clouds in Earth's atmosphere, noctilucent clouds. It is suggested that charged particles penetrating the atmosphere to an altitude of 80-90 kilometers can contribute to the ionization of air and serve as condensation nuclei for tiny ice crystals. Thus, the celestial fire may indirectly affect the weather at the very edge of space, creating the finest, ethereal clouds visible only at twilight. An aurora is not only visible light, but also invisible X-rays. When high-energy electrons from the solar wind are abruptly decelerated in the upper layers of the atmosphere, they emit what is known as Bremsstrahlung, or breaking radiation. Fortunately, it does not reach the Earth's surface, being completely absorbed by the thick layer of air above us. But it can be detected by scientific instruments on high-altitude balloons or satellites. This is the invisible part of the aurora's spectrum, its hidden, harsher, and more dangerous nature. Earth is not the only artist in our solar system capable of painting with light. Even comets, those icy wanderers from the far corners of space, have their own, albeit temporary, auroras. When a comet approaches the Sun, its icy nucleus begins to vaporize, creating a cloud of gas around it, the coma. The solar wind interacts with this gas, ionizing it and causing it to glow, typically in the ultraviolet range. Each comet that flies past us carries its own small, personal, invisible aurora. The aurora is not only a beautiful, but also a destructive process that constantly, very slowly, erodes the Earth's atmosphere. The energetic particles of the solar wind not only cause the gas to glow, but also impart enough energy to oxygen and nitrogen atoms for them to permanently leave the planet and escape into outer space. This process is very slow, but over the billions of years of Earth's existence, it has carried away a significant portion of its original, denser atmosphere. The aurora is the price we pay for the protection of the magnetic field. There is a phenomenon that is, in a sense, the opposite of the aurora, although much less noticeable. It is called airglow. This is a very faint, almost uniform glow of the entire planet's atmosphere that occurs constantly, day and night, at all latitudes. It is caused by complex chemical reactions between atoms and molecules, excited by sunlight during the day. At night, far from cities, it is this glow that makes the sky not absolutely black, but dark grey. The aurora is just a bright and local flash, against the backdrop of this eternal, barely perceptible whisper of light. If our vision were naturally sensitive to ultraviolet radiation, we would see that auroras are much larger and more complex than they appear. In the ultraviolet, it is not just the area where electrons precipitate that glows, but the entire polar cap, reflecting sunlight from helium ions. We would see a global phenomenon, covering vast territories and having a complex structure. But to our imperfect vision, only its brightest, most dynamic and beautiful part is visible, the one intended for poets, not for instruments. Every flash of the aurora, every ribbon of light, is absolutely unique, like a snowflake or a fingerprint. The pattern of light never repeats itself exactly twice. It depends on a myriad of factors. The density and speed of the solar wind at that moment, the direction of the interplanetary magnetic field, the current state of the Earth's magnetosphere, and the density and composition of the atmosphere at a specific point. To observe the aurora is to witness a completely unrepeatable moment, a work of art that is born and dies right before your eyes. In the folklore of some northern peoples, for example, in Alaska, it was believed that if you look at the aurora for too long and too intently, you could go mad. This myth was likely born from the incredibly powerful, hypnotic, mesmerizing effect of the slow dance of light. It is capable of completely absorbing a person's attention, stopping their inner dialogue, and immersing them in a state close to a deep trance. This, of course, is not madness, but rather a profound meditation induced by the direct contemplation of the living cosmos. Modern aurora hunters are an entire international community of people, from ordinary tourists to professional photographers and amateur scientists who travel the world in pursuit of the best shots and experiences. They use special applications to forecast the aurora, monitor solar activity data around the clock, and are ready to dash off in the middle of the night to a distant and cold place for a single good shot. For them, this is not just a hobby, but a true passion, a lifestyle dedicated to chasing the fleeting celestial beauty. Sometimes, during moments of particularly high activity, the aurora can take the form of a giant spiral, slowly and majestically rotating in the sky. This happens when the streams of particles causing the glow are twisted into a powerful vortex, similar to water going down a drain or the winds in the center of a hurricane. This form is particularly impressive and involuntarily brings to mind the spiral arms of distant galaxies. It is a kind of fractal semblance of the universe, manifested for a few moments in the sky of our small planet. Despite the fact that the aurora is inextricably linked to Earth's magnetic poles, it very rarely appears directly over them. The auroral oval, as we remember, is a ring that surrounds the pole but is not located over it. Moreover, the oval is always shifted towards the night side of the Earth. Therefore, if you were to miraculously find yourself at the geographic North Pole, you would most likely have to look south to see the northern lights. The geography of this celestial phenomenon is full of such quiet and surprising paradoxes. The aurora can be not only green, red or violet, but can also appear pure white, especially to the human eye at low light intensity. But sometimes, even at high brightness, it looks white. This happens when emissions from different gases and from different altitudes mix at one point, for example, green from oxygen and pink from nitrogen. To our perception, such a mixture of complementary colors gives the sensation of white light. This is true celestial alchemy, mixing primary colors into a single, pure radiance. The study of auroras on Earth helps us understand not only the processes occurring on our planet, but also the fundamental physics of plasma in general. Plasma is the fourth and most common state of matter in the universe. Stars, galactic nebulae, and the interstellar medium are made of it. Earth's magnetosphere is a unique natural laboratory where we can study these processes up close, not millions of light years away. The aurora is the visible result of experiments that nature conducts for us itself. There is a common myth that auroras can directly affect the operation of electronics, such as mobile phones or cameras, right on the ground. This is not the case. The electromagnetic disturbances capable of this occur too high in the atmosphere and do not reach the surface. However, during very strong geomagnetic storms, serious interference in radio communications can indeed occur, especially on short waves that are reflected by the ionosphere. The aurora interacts with our world at the level of invisible waves, not direct physical impacts. The color of the aurora depends not only on the type of gas that is glowing, but also on the energy of the particles bombarding it. More energetic particles have greater penetrating power and reach deeper layers of the atmosphere, causing a glow at low altitudes where nitrogen predominates, pink and blue tones. Less energetic particles are slowed down higher up, in the realm of rarefied oxygen, green and red. Thus, the color of the aurora at any given moment is a kind of celestial thermometer, indicating the energy of the cosmic rays bombarding our planet. The very first scientific sketches of the aurora, devoid of mythological fear, were made as early as the 16th century by European scientists. People tried to document its bizarre forms as accurately as possible, even though they did not understand their nature. These ancient engravings and drawings, depicting celestial fires, spears, and dragons, are today a priceless historical testament to how our perception of this phenomenon slowly changed, from a divine sign and a bad omen to an object of pure scientific interest and aesthetic admiration. In some languages, for example, in English, the aurora is called simply the Northern Lights. This simple and concise name perhaps most accurately conveys its true essence. It is not a dawn, not a fire, and not a dance in the literal sense of these words. It is simply light. A quiet, cold, mysterious light, born at the very border between our world and infinite space. A light that reminds us that even in the deepest and coldest darkness, there is always room for a miracle. Observing the aurora teaches humility and patience. Standing in silence under this silent yet grandiose celestial spectacle, one feels with particular acuteness one's own smallness, fragility, and at the same time, one's inseparable connection to something vast and eternal. All earthly cares, anxieties, and vanities recede, dissolving in the face of this cosmic majesty. All that remains is pure, quiet contemplation, and a feeling of deep, resounding peace within. Our distant ancestors, lacking scientific explanations, were perhaps in some ways closer to the true essence of the aurora than we are today. They felt its living, animate nature, saw in it a message, a dialogue, a sign. We, on the other hand, knowing all about protons, electrons, and the magnetosphere, risk losing that childlike sense of mystery and awe. True wisdom, perhaps, lies in combining knowledge and reverence, in seeing both the physics and the poetry in the celestial dance simultaneously. Sometimes, during moments of exceptional brightness, the aurora is so bright that it casts faint, greenish, moving shadows from trees or from the observer themselves onto the snow-white snow. Picture this scene: the absolute silence of the polar night, white, untouched snow, and on it, faintly visible, shimmering shadows from the light that has come from the depths of space. This is one of the rarest and most magical phenomena associated with the aurora, a moment when the boundary between sky and earth is erased, and they begin to cast shadows on each other. In 2018, Finnish researchers, analyzing photographs by enthusiasts, discovered another strange and new auroral phenomenon, the dunes. These are amazing wave-like structures in the green glow, resembling sand dunes on a seashore or ripples on water. They appear at an altitude of about 100 kilometers and are thought to be caused by a special type of atmospheric gravity waves. This is another example of how the sky mimics the earthly landscape, drawing with light forms that are familiar and understandable to us down here below. The speed of the solar wind particles that cause the aurora averages from 300 to 1,000 kilometers per second. This is thousands of times faster than the speed of sound in the atmosphere. When this furious, invisible stream crashes into the Earth's magnetic field, a silent but colossally powerful battle takes place, an invisible collision of two elements. And the gentle, graceful dance of light in the sky is merely the visible result of this battle, its beautiful and silent outcome. The intensity of geomagnetic storms and consequently of auroras is measured on a special global scale called the KP index. It has values from 0 to 9. A value of 0 means complete geomagnetic calm, while 9 is an extreme planetary scale storm, similar to the Carrington event. Most auroras visible to the naked eye occur at a KP index of 3 to 5. This scale is merely an attempt to measure poetry with numbers, to translate the living language of the cosmos into the dry language of science. Even our companion, the moon, can influence how we see the aurora. A full moon, with its bright flooding light, greatly increases the overall background brightness of the sky, washing it out and making faint, delicate auroras completely invisible to the eye. Therefore, the best nights for observation are moonless nights around the new moon, when the darkness is at its maximum. Moonlight and auroral light are two nocturnal luminaries that rarely act in harmony, more often competing for the attention of a solitary night observer. In many hotels in Iceland, Norway, or Finland that specialize in aurora tourism, there is often a special and very touching service, an aurora alarm. A special hotel employee stays on duty all night and watches the sky. And as soon as an aurora appears in the sky, they call or knock quietly on the doors of guests who have signed up for this service so that they don't miss the long-awaited spectacle. This is a simple act of human kindness, born from a sincere desire to share the wonder with others. Sometimes during very calm moments, when solar activity is minimal, the aurora can look like a large, motionless, completely diffuse cloud of a faint greenish color. It can even be mistaken for an ordinary cirrus cloud, backlit by a distant moon or city lights. But if you look more closely, it becomes clear that stars are distinctly visible shining through it. This is the quietest and calmest state of the aurora, its sleep, its deep repose before a new dance. The fastest and most dynamic movements that can be observed in the aurora are called ray tracing by scientists. This is a phenomenon where individual thin rays of light begin to rapidly, one after another, run along the arc of the aurora, like the fingers of an invisible pianist running across the keys of a giant celestial piano. The speed of this visible movement can reach 100 kilometers per second, creating a sense of incredible, almost musical dynamics. The Earth's magnetic field is not static. Its poles are constantly drifting, albeit very slowly. Currently, the North Magnetic Pole, to which the auroral oval is tied, is moving from the Canadian Arctic towards Russian Siberia at a constantly increasing speed. This means that in the future, over hundreds of years, the zone of best visibility for the auroras will also gradually shift. The map of celestial wonders is slowly but inexorably being redrawn. The aurora is not just a visual phenomenon. It also generates natural, very low-frequency radio waves that can be recorded with special antennas. These waves, when converted into audible sound, resemble a strange mixture of birds chirping at dawn, whistling and whispering. Scientists call them chorus waves. This is another secret voice of the aurora, which can only be heard with the help of instruments. Space sings its quiet, strange song, and we are just learning to listen to it. In 2007, a NASA mission called Themis, consisting of 5 identical satellites, was able to pinpoint for the first time where and how magnetospheric substorms, which cause the brightest auroral displays, are born. It turned out that the short circuit and reconnection of magnetic field lines occurs in the Earth's magnetotail, at a distance of about 1/3 of the way to the Moon. Science was able to find the exact birthplace of this magic, but this knowledge has not diminished its mystery and beauty in the slightest, but has only added depth to them. Many people, upon seeing a bright aurora for the first time in their lives, experience a profound emotional and even physiological shock, sometimes compared to Stendhal syndrome, a state of dizziness, rapid heartbeat, and trembling that some people experience before great works of art. This is the best reminder that beauty in its highest natural manifestation is capable of affecting us on the deepest level, going beyond mere aesthetic pleasure. The aurora is an eternal reminder of the fragile, almost unbelievable balance in which life on Earth exists. It is beautiful precisely because it is born on the very border between protection and danger. Our magnetic field saves us from destructive solar radiation, but the interaction with this deadly radiation itself gives birth to the most beautiful and serene spectacle on the planet. Beauty is born in struggle, on the very edge of the abyss. The aurora never descends to the ground itself. It always remains up there, in the cold and rarefied layers of the atmosphere, on the border with space. It teases us with its apparent closeness, but always maintains an unattainable distance. It is an eternal celestial dance that we can only watch from below, feeling our inseparable connection with the cosmos, and at the same time, our eternal attachment to the solid ground beneath our feet. Imagine for a moment the absolute silence of the polar night. A complete, ringing silence where the only sound is the barely audible crunch of snow underfoot and your own slowed breath. And in this deafening silence, directly above you, filling the entire sky, a silent, majestic dance of light unfolds. This experience is akin to the deepest meditation, when the outside world falls completely silent and all that remains is you and the sky, carrying on your silent dialogue. The light of the aurora is the light of countless excited atoms returning to their original, calm state. Every single photon that reaches the retina of your eye is the finale of a tiny atomic drama, played out at an altitude of 100 kilometers above the Earth. Billions and billions of such microscopic dramas, merging together in space and time, create this majestic fluid canvas of light. The aurora is woven from countless acts of calming, and when the celestial performance slowly comes to its end, the light does not go out suddenly. It slowly fades, melts, dissolving into the velvet of the night. The ribbons grow paler, the arcs break up into separate patches, and soon only a faint greenish afterglow on the northern horizon recalls the former splendor. The sky returns to its usual starry state, but something imperceptibly changes within the observer. A quiet knowledge remains that above us there is always this hidden wonder, which is simply waiting for its moment to begin its dance once more. Thus, in the silent dance of light, the cosmos reminds us of its presence. Every flash of the aurora is a letter written by the solar wind on the canvas of our atmosphere, a letter about unity, about fragility, about the incomprehensible beauty of the universe. And we, standing on the frozen ground, become its silent readers, allowing this light to fill us with peace. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul after another. And now, just breathe. Let your eyes grow heavy, and let the quiet lights of the north lull your thoughts. Good night.